Hello and welcome to C++ Weekly. I am your host, Jason Turner. I am available for code reviews and on-site training, and you should find me at an upcoming conference near you. I want to do an episode on how constexpr can catch memory leaks. I'm going to do the short version of this. This is an exercise that I often do with students. I've occasionally done in conference presentations that are not recorded. But I really want you to understand the value of using constexpr for catching undefined behavior, memory leaks, memory errors, all that kind of thing. And to illustrate this, we're going to make a very, very simple, unique pointer implementation. It has an integer pointer in it. And I'm going to give it a constructor. And the constructor is going to take an integer pointer like this, and I am going to give it a default constructor that I am going to explicitly default. There. That is my unique pointer implementation. I'm sure you think that it looks 100% complete and usable. So let's go ahead and test this. I'm going to just have a main, and I'm going to default construct one of these things. Unique pointer p, default constructed. Unused variable. That's not a very helpful warning in this case. I just want to make sure that I can default construct this thing. So let's go ahead and mark this as maybe unused. Now I'm going to create one that has an actual value in it. So this works. I can create a pointer, and it has an object that it points to, and I can run my test, and all my tests pass, and clearly this code is good. I have 100% code coverage, right? So everything works. But you're probably looking at this saying, hey, there's a memory leak, and there's a memory leak. And you might also notice that the compiler has optimized away the memory leak, which I have mixed feelings about. So I'm going to show you the power of constexpr for testing. I'm going to use the C++26 const-eval block to do this. So I'm just going to put this thing inside of a const-eval block, and that's going to force this thing to be executed at compile time. Now the compiler still has no problem with this. That's great. And I'm going to go ahead and make this a const-eval block as well. And this should also work. Well, it should work up to a point. There's going to be a couple of compile time errors. Now, this thing was explicitly defaulted, and an explicitly defaulted special member function will implicitly be constexpr if the implicitly defaulted version of that member function could have been constexpr. So that's already constexpr, so that's not going to cause a problem for us. But I've got a problem here that this constructor, the constructor that I am explicitly defining, is not constexpr. So I needed to make this constexpr so that this code will compile. But I'm going to get a follow-up compile error. And that is because my dereference operator is not constexpr, the unary star. So I'm going to go ahead and make that constexpr. Now I get another compile error. And this compile error is because allocated storage has not been deallocated. Oh, this is actually a very powerful error for me. So I am going to make sure that I actually have a destructor, because I am manually managing resources. And I just make a quick note to say, remember, don't do this. Use standard library functions that do it for you, like unique pointer. Okay, this is going to be another compile failure because the destructor is not constexpr. And I just want to point out that yes, as of C++20, I can make my destructor constexpr. Okay, great. Oh, the compile error moved. Now, just for the record, I'm not actually surprised. I knew exactly what was going to happen here. I know some of you comment about, like, why do I record videos when I have no idea what's going to happen? I did know exactly what was going to happen in this particular case. And what was going to happen is I am getting now the compile failure moving back to the top block because I never initialized PTR. So I am accessing an uninitialized value on line 13. Now, delete of a null pointer is in fact well-defined behavior. So this is mostly the correct way to write this. And now you'll notice that by using constexpr testing, I caught the memory leak by not having the destructor, and I caught the uninitialized member variable use. And this becomes the case where if the code compiles, then it is probably correct. So let's go ahead and test our copy operation right now. So I'm just going to say unique pointer is not copyable. But this helps us actually understand why unique pointer is not copyable. I tried to do a copy construction and I'm going to get this error that there has been a double free. This is again a compile time error. Oh, you're right. I shouldn't have allowed that to happen. So let's go ahead and make the unique pointer copy constructor deleted. So now this code fails to compile, and I am going to go ahead and make this a move. And I am going to expect this to fail to compile as well. Use of deleted function, copy constructor. Oh, but wait, why are you telling me that I am calling the copy constructor here? I'm not. I'm trying to initialize this with the result of an R value. This is a move operation. Well, I deleted the copy constructor, which means I have to provide my own move constructor. So if I provide my own move constructor, let's just go ahead and default it. No, compiler, please make the defaulted move constructor for me automatically. Then I get a double free again because the explicitly defaulted move constructor is going to do a member-wise move of the elements of the type and a move of a scalar type, such as a pointer, is just in fact a copy. So I need to actually properly implement this. And a beautiful way to implement this, probably my most favorite way, is to say I want to initialize pointer with the result of the exchange of other dot pointer and null pointer. So this is basically going to do a left shift of those values such that my pointer is initialized with other dot pointer and other dot pointer is updated to null pointer. And I am going to have to make this function constexpr as well, and you can see that I have fixed the double free and I have fixed the memory leak, and all of my tests pass. Do not underestimate this. This is an incredibly powerful tool for ensuring the correctness of your code. Make sure you use this. This is one of the reasons why I've been trying to push for constexpr all the things for the last decade. Yes, in fact, it has been 10 years. Thank you for watching this episode of C++ Weekly. Be sure to subscribe. I will catch you next week.